All right, hi everyone. So today this video is about depth first search algorithm, and just to give you an idea that I've been preparing for a job switch. Basically, I want to switch my job. So I am preparing DSA and kind of revising the previous concepts and so today's GFG problem of the day was based on DFS, and while solving that, it made me realize that I've forgotten DFS quite a bit. So that's why I brushed up on the topic and solved some 10 to 12 questions on DFS. And while solving those questions, I figured out a template, a single template using which most of the DFS questions were being solved easily. So I'll be sharing my template with you, as well as we'll go through the questions, few of the questions which I solved, and how that template is applicable everywhere. So to give you a brief idea of depth first search, basically in this algorithm, suppose we have been given this graph. Okay, so what happens is we go inside, we go deep. So what happens, suppose this is the starting node, okay, 1. So from 1 we go to 2. Now from 2, whoever its neighbors are, we go deep into it. Okay, we will not first look for all the items adjacent to 1. No, we will go deep. Now from 1 we came to 2, from 2 we'll go down and 4. Now from 4 we see that we do not have any adjacent nodes which are unvisited yet, right? So we start backtracking. Okay, now again we were left with one node when we visited 2, so we'll visit 5. Then again we have visited it, so we backtrack again. From 2 we backtrack to 1. Again from 1 we go deep down to 3 and we backtrack again. So this is a gist of the depth first search. Now I knew this gist very perfectly, still I was not able to code it up properly. So here's my template which can help you solve any depth first search question. So this is the template basically. Whenever you have to carry out a DFS, please note that you need to have one starting node. One starting node is very very essential for a DFS. Okay, and this you will understand when you solve a certain number of questions. Okay, you will understand that how we are gathering the starting node. Okay, now as soon as we get the starting node, we like start our DFS from that. So here we were starting the DFS from 1. Okay, now we need to maintain one visited. Now visited can be an array or it can be a matrix depending on the question, but we need to have some data structure which will give an give us an idea if the current node has been visited already or not. So suppose right now what happened was I visited 1, okay, and I marked it true. Okay, now when I came to 2, okay, I have to see from where, in which all directions I can go from 2. I can from 2 I can go to 1 and 4 and 5, right? So why did I choose 4? Basically, if even if we come sequentially, I could have chosen 1, right? Or even if not sequentially, even if suppose I go across 4 and 5, I will have 1, right? But we cannot visit 1 again, right? So we need some data structure which tells us that okay, we have visited 1 already. We need not go there again. So this is what we are doing here. We are just, whenever we start DFS on any particular node, we mark it as visited, right? Now after this, here I've commented this portion, but it is probably one of the most important parts of this algorithm, where this is the portion where you will handle your logic, the programming logic which the question desires. Okay, okay, now this we will come to when we move through these questions. Yeah, after this what you have to do is we have to look for the adjacent nodes. Like here we are looking for the adjacent nodes, so we'll look for the adjacent nodes, and of course if it is not visited, then we will carry out DFS on that. As simple as that. Only these like 4 5 lines, like bare minimum we have 4 5 lines of code here, and that's it. We need to know to perform a DFS on any question. Okay, so now let's move to question number 1, where we can check how this template is working. So yeah, so first question was this word search problem, only because I solved it today morning. And yeah, so here how we are applying. So word search, for word search a solution, if you want you can see my other video. So here I'll not cover what the problem was, but what we had to do was we had to carry out DFS from the starting character of a word. Okay, from the starting character of a word, which is very important. So what we did was we started DFS. Okay, we figured out the starting indexes and we started DFS. Inside DFS, what is happening? We marked visited as true. We have mentioned visited should be marked true. Okay, then what we did was programming logic. This is the programming logic in in this particular problem. We had to basically find if a word if a word is completely present inside the matrix or not. Okay, and this is the logic which is helping us do that. Okay, third part is iterate over its adjacent nodes or directions in case of matrix. Here we had a matrix, so we had the four directions to iterate on. So that's what I did. I iterated over the four directions, calculated the new row and new column based on the directions, and again, if not visited here, that's what it has been mentioned. If not visited, then only we carry DFS uh, in the further nodes. Okay, and this programming logic is according to the question. So there will be minor changes with respect to the question, but the overall the template remains the same. Okay, so this is the word search problem, which is today's problem of the day in Geeks for Geeks platform. Moving on to the second question which I solved today. This is number of islands. Okay, this is a very famous question. It can be solved using both BFS and DFS. Today my criteria was DFS, so I solved it using DFS. So here what we have to do is we need to find the number of islands. So islands are basically all the ones when connected together they form an island. That's the whole gist of the question. So again, I need one starting point. I need one starting point. Now I know that if it is a one, it's an island. And now I need from this one, I need to connect all the other ones which are adjacent, right? So that's what I did. I found the first one I'm getting. And of course, if it's not visited, because we may have multiple islands. Now I'm not going too much into the question because I'm more concerned with the DFS. Okay, so yeah, if it is one, and now we are calculating DFS. Okay, again we have a starting node. Now in matrix, instead of node, you will have the indexes for the row and column, right? So here I have the indexes. Okay, again, first line is visited of node true. First line is visited of RC true. So we are marking it as visited. Now here it said any programming logic which we want to add according to the question. So here no programming logic was required. The programming logic is present here. This is as per the need of the question. Okay, then iterated over the four directions because it's a matrix. So iterated over the four directions, calculated the new row and new column, added the constraints to check if it is valid. Again, if it is not visited and a programming logic, we are going for DFS. Okay, now let's move to the third problem. Pacific Atlantic water flow. This is a great question, actually. Okay, but this is like DFS twice. You have to do DFS. You have to do the same thing twice. So here the requirement was something like we need to find the cells from where water will flow into both of these oceans. Okay, so basically we had to carry out DFS twice, once for the Pacific Ocean and once for the Atlantic Ocean. Okay, now for I will give the problem links in the description, and I do not want to spend much time on the question explanation and stuff because all that you can go through. My whole point of this video is DFS and the template I'm talking about. Okay, so yeah, here also again the same thing. We are starting DFS. We have found out the initial starting point. That's this is an important point. Whenever you solve questions, you need to know where to start the DFS from. Okay, so we have figured out that and we have started DFS. Now inside DFS again the same visited true. Now this is according to the problem logic. Okay, again we are going through all of the directions and doing the same DFS. Again a small programming logic here according to the given question. So till now we have seen three questions and all the three questions had the same the same template, right? So that's what I'm talking about. This template is really helpful, and it's not a template. Basically it's the algorithm. Okay, but when we see template, our mind makes it feel easier, and we somehow believe that it's some magic which will help us solve all the questions. And even if it feels like magic, then that's fine. Okay, because at the end of the day we need to solve the questions in an interview, right? And And during the interview, if we think about these small things, whether we should mark it visited here or we should mark it visited here, all that small confusions, they just add up during the interview. Okay, that's why I'm trying that I have certain templates for all the algorithms. Okay, this is the first video, and I'll look for other templates. Okay, I'll try to work on other algorithms and bring their templates as well. So yeah, let's move to the fourth question, which is shortest bridge. Now this is a great question, and the only point of adding it to this video was it has both DFS and BFS. Okay, so here what happens is basically here there are two islands in the grid. Okay, exactly two islands have already been given to us in the grid. So we need to find the shortest distance between those two islands. So the first so like basically we have to do first we have to do DFS and find out the first island, whatever it is. Okay, so suppose I found this one. Okay, now this will serve as the island. Okay, so as soon as I found the first island, I have to start BFS from its surrounding edges to the second island. Okay, this is a great question. I'll really suggest you to solve it on your own. But from here, yeah, so we start we try to find one of the islands, and we only need to find one of the islands. That's why I break out of the loop. Again, the same DFS logic. We find a starting point, we mark it as visited. This is the programming logic over here. Okay, this is a place where we are doing this third part, which is uh, iterate over the adjacent nodes. Okay, but this over here, this is the programming logic, this is the demand of this question, where we are looking for the land, basically land uh, surrounding this particular water cell. Okay, so this is for that. And again, same criteria here, we are moving in all the four directions, we are calculating the new row and new column, and again we get this, this is the basic DFS logic and this is the programming logic, and we calculate DFS. That's it. After we calculate DFS, we have the required inputs, which is stored in this queue, and from this queue we carry out the further calculations, which are out of scope for this video. But yeah, so this will be it. So this is the template, this is a recursive template. Basically, I think whenever interviewer asks you to follow a DFS approach, maybe they are looking for a recursion, maybe they are looking for a recursion implementation. But in case we are going for, you want to also check a stack implementation, because recursion is basically stack, right? So if you create a stack of your own, the logic remains the same. Just create a stack, mark the starting node as true, push the starting node to stack. And now, as long as the stack has some values, we bring out the top value, and again we visit the adjacent nodes and we mark the visited as true. That's it. This is really simple. Okay, if you want to take a screenshot or take a screenshot of this template, you can, and just copy paste this and try to solve maybe at least 6 to 7 questions of DFS today, so that you get acquainted with this framework particularly. Okay, and yeah, let's see, let's meet in the next video.